Let us evaluate the integral I equal to integral 0 to pi by 3 sine cube x cos square x dx. So this can be written as integral 0 to pi by 3. Now we can write one of the sine square x. So there is sine cube x. So write sine square x as 1 minus cos square x. So we will get 1 minus cos square x into cos square x, then there is the remaining sin x dx. Now we will use a substitution u equal to cos x, so du will be equal to minus sin x dx, and we have x varying from 0 to pi by 3. So when we take u will be cos x, so u will be varying from, so cos 0 is equal to 1, and cos pi by 3 will be equal to 1 by 2. So we will get integral 1 to 1 by 2, replacing cos x by u. So we will get 1 minus u square into u square. Now sin x dx will be minus du. Now using this minus sign, we can reverse the limits of integration. So we can write this as 1 by 2 to 1. 1 minus u square into u square du. So that will be equal to integral 1 by 2 to 1 u square minus u raised to 4 du. So upon integrating, we will get u cube by 3 minus u raised to 4 by 4 from 1 by 2 to 1. So at 1 we will get 1 by 3 minus 1 by 4 minus at 1 by 2, 1 by 2 whole cube will be 1 by 8. So we will get 1 by 24 as the first term, and 1 by 64 will come. So that will be equal to, so this difference will be 1 by 12 minus 1 by 24 plus 1 by 64. 1 by 12 minus 1 by 24 will be 1 by 24 plus 1 by 64. Now take the common denominator to be, take 64, 64 into 3. So here we will get, so this is already 8 into 3. So 8 will come on the numerator, and here 3 will come on the numerator. So we will be getting 11 by 192. So that will be the value of the integral. And here we need to evaluate the integral if it converges, and show divergence if it diverges. So this will be equal to integral 3 to 7, 7 minus x whole raised to minus 1 by 2 dx. Upon integrating, we will get 7 minus x whole raised to minus 1 by 2 plus 1 will be 1 by 2 by 1 by 2 into this minus 1 will come. Applying the limits from 7 to 3, we will get, so 1 by minus 1 by 2 will be minus 2. So we will get minus 2. At 7 we will have 0 minus, at 3 we have 4 raised to 1 by 2. So that will be minus 2 into 4 raised to 1 by 2 will be 2. So we will be getting the value as 4. So therefore the integral will be converging in this case. Now the second one, this will be, so here we will use a substitution u equal to 4 plus x square, then du will be equal to 2x dx, and since x varies from 1 to infinity, so if we take u will vary from, so 4 plus 1 will be 5, 5 to infinity. So we will get integral 5 to infinity. Now x dx will be du by 2, and 4 plus x square is u. So we will get integral du by 2u. So that will be 1 by 2 log u from 5 to infinity. And when we apply the limit, log of infinity will be equal to infinity. So therefore it's not finite. So the integral will be diverging in this case. And next one, by the method of cylindrical shells, we need to find the volume generated by rotating the region bounded by the curves y equal to x square and y equal to 4x about the x-axis. So we need to apply the method of cylindrical shells. So let us first look at the curves given. So we have y equal to x square. The region is bounded by y equal to x square and y equal to 4x. So this will be the graph of y equal to x square, and y equal to 4x will be this line passing through the origin. So this will be the common region. Now let us find these points of intersection. So at the points of intersection, both the graphs must coincide. So we will get x square equal to 4x. So that will give x square minus 4x equal to 0, or x into x minus 4 equal to 0. So we must have x equal to 0 and 4. So when x is 0, again y will also be 0. So this point of intersection will be 0, 0. And when x is equal to 4, we will have y equal to 4 square, or both will give us 4 square. So y will be equal to 16. So this coordinate will be 4, 16. So this will be the points of intersection. Now we need to rotate this about the y-axis. So by the method of cylindrical shell, so we'll be having a cylinder like this. So if this is the height of the cylinder, then when we rotate this portion, we will be getting a cylindrical part like this. So we need to do this for all x varying from 0 to 4, and here the height h of x will be equal to, so height will be, when we take this strip, the above part will be 4x and below we have x square. So height is going to be 4x minus x square, and volume will be given by, so volume will be equal to integral 0 to 4 2 pi x into h of x dx. So that will be equal to integral 0 to 4 2 pi x, and h of x will be equal to 4x minus x square dx. So we can take 2 pi outside, then remaining we have 4x square minus x cube. So integral of 4x square will be 4x cube by 3, and integral of x cube will be x raised to 4 by 4 from 0 to 4. So upon applying the limit, we will get 2 pi. So when x is 4, here we will get 4 raised to 4 by 3 minus 4 raised to 4 by 4. So that will be 2 pi into 4 raised to 4 into 1 by 3 minus 1 by 4 will come, that will be 1 by 12. So we will get 2 pi into 4 cube by 3 will come, so that will be 64 by 3. So we will be getting 128 pi by 3. So that will be the required volume. Next problem, a water tank has the shape of a sphere of radius 2 meter with a spout on top of length 1 meter, as in the following picture below. The spherical part of the tank is full of water and the spout is empty. Set up but do not evaluate an integral to find the work required to empty the tank by pumping all the water out of the spout. So we may use rho equal to 1000, which is the density of water, and g equal to 9.8, which is the acceleration due to gravity. So we are given a water tank which is in the shape of sphere, and as shown in the figure, it has radius 2, and it is said that the spherical part of tank is full of water. So the entire tank contains water. Then we need to find how much work is required to empty the tank by pumping all the water out of the spout. Okay, so what we do here is so there is water in the entire sphere. So let us consider different slices of water. Okay, so we can consider different slices of water. Now what we are going to do is we'll take out each slice of water, and that way we are going to empty the tank. So we will find what is the work required to empty one particular slice of water, and these slices of water will be there from -2 to 2. So we'll denote this direction from by x. So we'll find first what is delta W. So that is the work done to remove one slice of water. So upon integrating delta W from -2 to 2, we will get the total work done to empty the tank. So that is what we are going to do. So let us consider a point x here. So consider a slice of water at x. So let us so here we'll get a cylindrical slice. So let this distance be r, and this distance will be x, and this will be equal to 2. So we will have r square by Pythagoras theorem, r square, so x square plus r square will be equal to 2 square. So we can write r square equal to 4 minus x square. Now let us take this slice to have a height delta x. So we are having a slice of very small height. So let the slice have height delta x. Then if delta x is the height of the slice, so this will represent a very small cylinder. So its volume is going to be equal to pi r square into delta x. So pi r square h will come, so that will be pi r square delta x. So that will be pi r square. So pi r square. So we can replace r square by 4 minus x square. So we will get pi into 4 minus x square delta x will come. So this is the volume of this very small piece, or that is actually delta V. So delta V will be equal to pi 4 minus x square into delta x. Now we are given the density of water to be rho equal to 1000. So we have the volume of this very small sheet of water. Now by density we mean density is mass per volume. So therefore mass of this slice will be equal to 1000 times delta V. So the mass of the slice of water will be equal to rho into delta V. So that will be equal to 1000 pi 4 minus x square delta x will come. And now we know that force will be equal to mass into gravity. Force will be equal to mg. So delta force will be equal to delta mass. So that will be, all of this will be for this slice of water. So delta mass into g will come. So that will be 1000 pi 4 minus x square delta x into 9.8 will come. So we will get 9800 pi 4 minus x square delta x will come. So that will be force required to do the work. So now we can find delta W. So delta W will be work done will be force into distance. So work done will be delta